Okay, on the first lesson we looked at the basic rules for differentiation, and we said that we would multiply by the power and reduce the power by 1. Now sometimes the functions don't come to us in a nice form like that, and we need to make sure that they are in a form that we can multiply by the power and reduce the power by 1. And we do that by using our knowledge of indice rules. So we're just going to do a quick recap of the indice rules that we learned last year. The square root of x can also be said as x to the power of 1/2. The cube root of x is x to the power of 1/3. The square root of x to the 5 is x to the power of 5/2. Now the 2 there, the halves part, came from the fact that it was a square root, and the 5 was because it was to the power of 5. So x cubed to the 5th root is x to the power of 3/5. The denominator comes from the order of the root, and the numerator comes from the power. Pause the video for a second and try these 4 below. Okay, so now we can check how did you do. X to the 7/4, x to the 3/4, x to the 2/5, x to the 8/2, which is the same as x to the power of 4. So we've looked at the indice rules for fractional indices, and now we're going to look and remind ourselves of the rule when x is in the denominator of a fraction. 1/x squared is the same as x to the -2. 1/x to the 4 is the same as x to the -4. Just be careful when there are other numbers involved, because the number's not going to move anywhere. That 2 in this example here is going to stay on the bottom, even although the x cubed is going to come up. So we can say this in 2 ways. It's either 1/2 of x to the power of -3, or it's x to the -3/2. If you're not confident with these rules, please go and try the essential exercises that are in the back of your textbook. There's a note of which questions to do in your team's class notebook. Okay, just a couple of more examples where there are other numbers involved. So 3/x to the power of 7 is the same as 3x to the -7. 3/4x squared is the same as 3/4 of x to the -2. I could also say that it's 3x to the -2/4. Because we're doing this in preparation for differentiation, I would like to keep the coefficients separate so that I'm reminded when I multiply by the power and reduce the power by 1, it will be a little bit easier for me to understand what the coefficient of my derivative is going to be. Okay, now we're going to use those rules we've reminded ourselves about to prepare a function, then we're going to do the differentiation. We're going to go straight to our notes, so this is page 3, and the first example that you're given, f of x is equal to the square root of x. Now before I differentiate that, I need to use my indice rules to turn that to a fractional indice, and I know that square root means to the power of 1/2. Now I'm going to differentiate, so I'm going to multiply by the power, which is 1/2, and I'm going to reduce the power by 1, which is -1/2. Now I'm going to tidy this up the 1's staying on the top, this 1's staying on the top, this 2 is staying on the bottom. The x, because it's negative here, that tells me I want to put it on the bottom to make it positive. The fact that it's a half tells me it's a square root. So I can tidy this up as 1 over 2 times the square root of x. Example number 2, I've got a function which is 1 over x squared. I can't differentiate that at the moment because x is in the denominator of a fraction. I need x to not be under a root of any kind, and I need it not to be in the denominator. So I'm going to use my indice rules to bring the x to the top. So if 1 over x squared is the same as x to the negative 2. Now I can differentiate. So I'm going to multiply by the power, which is negative 2, and I'm going to reduce the power by 1, which is negative 3. I'd like to give my answer with positive indices only. So the fact that it's a negative 3, I can pop it on the bottom of the fraction, and it will become positive. So it's negative 2 over x cubed. Okay, the next example in your book has the function of x being equal to 2x cubed. There's no preparation I need there. X is not under a root of any kind, and it's not in the denominator of a fraction. So I can just go right ahead and multiply by the power. So 3 times 2 is 6. And reduce the power by 1, which gives me squared. I've got a positive non-fractional indice for an answer, so I'm happy that I don't need to tidy it up. Okay, the next example has f of x equal to 4x to the power of negative 2. Now actually in your notes you'll notice that in this case and a couple of others it says y equals here. There is a different set of notation that we'll learn about in a couple of lessons called Leibniz notation. I'm going to stick with the functional notation today because I don't want you to get confused. So just everything we do, we'll do in functional notation at the moment. We're focusing on the basic rule of differentiation and the 2 indice rules that we've reminded ourselves of. So in this case I don't need to do any preparation because it's already been prepared. X is not under a root of any kind, and it's not in the denominator of a fraction, so I can go right ahead and differentiate. So I'll multiply by the power, so negative 2 times 4 is negative 8, and I reduce the power by 1, which gives me negative 3. Now I am going to want to tidy that up, because I don't want a negative or fractional indice in that answer. So to make that positive, I'm going to put it underneath the fraction. So negative 8 over x cubed. Okay, number 3, this time the function is 2 over x cubed. We're going to need to prepare this because x is on the denominator of a fraction and we can't have that. So to bring it up, we're going to make it a negative indice. So I've got 2x to the minus 3. Now I can differentiate. I'll multiply by the power. Negative 3 times 2 is negative 6. And I'll reduce the power by 1, which is negative 4. I'll tidy it up so that I don't have a negative indice in my answer. Negative 6 over x to the power of 4. Okay, Okay, your last example, which is now on page 4. Again, they've used Leibniz notation, but I'm going to stick to function notation for the moment. It's 3 over 2 root x. Now, this function has two things that we need to address before we differentiate. X is on the denominator of a fraction, and it's under a root. So we're going to need to find a different way of saying 1 over the square root of x. The 3 staying where it is and the 2 staying where it is. So I'm going to write them first of all. The x at the moment is on the denominator. If I want to bring it to the top, I'm going to need to have a negative in this. The fact that it's a square root, I know that's to the power of a half. Now I'm in a situation where I can differentiate. So I'll multiply by the power, but negative a half times 3 halves is going to be negative 3/4. X, I've already got negative a half, I'm subtracting 1, so it's going to be negative 3 halves. I want to tidy it up. It's negative in this and it's fractional. The fact that it's negative means that I'm going to pop it underneath beside the 4. The fraction, remember, the denominator tells me the order of the root, so it's a square root, and the 3 tells me the power. So this is the same as negative 3 over 4 square root x cubed. Okay, so we've done quite a few examples today. I just want you to have a little bit of a check that you've understood the things we've covered. So can you answer these questions in your jotter, please, using sentences? What are the 2 things that we need to address before we can differentiate? These don't necessarily occur in every function, but we need to check for them. In a fractional indice, what does the denominator tell us and what does the numerator tell us? And here we're thinking about the tidying up that we do after we've differentiated. What does the number on top tell us and what does the number on the bottom tell us? Okay, we're now in a position where we can continue with the exercises we've started. So exercise 6D, we can do question 12 to question 40. And exercise 6F, we can do question 8 to question 27. We'll be focusing on the harder ones when we're in class together.